We today hear about, we will talk about how to connect IoT and DevOps, the open source way. This is the reason why I don't only brought a colleague from Accenture, Alexander Menz, but also Loran from Red Hat to this talk. And just losing a few words about myself, I'm an IT consultant at Accenture, working for 4 years there, and I will take over the part about the basics, fundamentals, the core idea, how to connect, how to go forward with this whole topic, and bring IoT to DevOps or DevOps to IoT. Let's see.
Alexander Menz, with Accenture 17 years. I'm Senior Technology Architect in the emerging technology area.
Oliver Horn, Senior Solution Architect, covering the alliances with our system integrator partners in Germany and Austria.
So, and as you all heard here, we are all from Germany. So, sorry for the accent. Good. Right. So after my part, it's the first part, we will go to the vision of Accenture with some nice nifty features about IoT and what we see about it. And then we also go over to Red Hat's vision, and that is more likely a closure to the base idea that I will present now first.
And maybe just a quick question, how many are aware of DevOps? Just so, okay. IoT?
Great. Are you working on IoT projects currently? Application and device-based? Oh, nice. I have questions afterwards. Good. So that is a good part. So some people of you already worked in DevOps. I won't provide a big explanation what DevOps is. I think we all have a great understanding. This is the reason why we're here on this conference also. It's a technology conference. But the main focus, what I want to go for, is the part that we don't only have developers and operators, we have also the QA team. That is pretty important. Also if you want to think outside of the box in DevOps. So I don't lose them. But the main point here is that it is always about continuous learning and continuous collaboration between those teams. You see, I have put up 3 key names, and the 4th is open, because these are mostly people that are outside the box. But it will be filled. We will see this. So DevOps, for itself, you know, it's a methodology toolkit. We have tried to move the past few years the legacy applications and the legacy processes to this new methodology to be more agile, to be more flexible, to develop new things. And I won't explain the full framework process of this, but this illustrates great the base DevOps part of how to start from a requirement of a plan, then build and test it after some development time, and then release and operate it. So on every side, you have always the responsibilities, not only on each side for one person or one group, but you have this always shared, because it's all about collaboration and learning, how I said on the last slide. This was the part about DevOps, right? So bringing people together at this point. If we go towards IoT, we see a little bit different history at this point. We started roughly in 2000 in logistics with RFID chips to track packages, containers, or whatever, to get an idea what is in a box. Afterwards, we went through the process to go for surveillance equipment, etc., connecting it to the network, not only having a tape directly attached to it, but yeah, you get the idea. Afterwards, we try to start tracking things, and not only things like a small device that is shipped, but big containers, or starting with this and then going forward. And on today's, just a quick question, how many of you have a smartwatch currently on? Yeah, I know you guys. I see it. So this these smartwatches are also IoT devices, right? So keep in mind what we will talk in a few seconds or the next minutes about and try to relate the things, the problems, the challenges, and the opportunities that we have to this kind of device. Right. I won't read the definition that's standing. I don't like reading at this point. But you get the key messages of it, that DevOps is still pretty widely defined. And this was the reason why I brought up the time scale for different devices in development. That we still don't know what this thing exactly is, but we use this. We use this, and we like this, because it's a service at the end that we consume. But like every service, it has a problem. We have in IoT projects, and maybe somebody can discuss this with me later on, but we have a failure rate of the projects roughly around 70%. This not only includes projects that really failed, but projects that are out of budget, out of time, not delivering the scope, not delivering the quality, are not fully tested. Let's say also some Kickstarter projects. They failed because they couldn't deliver at the end. Great idea, much money behind it, but then the developers left with the money and not delivering the project. Right. But most of the part that is providing this 70% or accumulating it is the sheer huge amount of devices that we have. I saw now roughly 10 people in this room who are wearing smartwatches out of 30. I think 5 years later, I think most of the people, or 60% of you guys, will wear a smartwatch. In 10 years, 15 years, we won't wear smartwatches, we will wear wearables. Like I can take calls with my jacket, something like that. So this amount of devices is really a huge problem, because we are not only heading toward that is getting even more, but we need to think about what is already existing. And the part that is already existing are starting with sensors in not only industry, but at your home. So many of your people maybe invested now or a few years back already in some IoT devices for managing your electric light, managing your garage door, or even your house door. And this is what I want to ask. How many of you are using Internet of Things devices in your home? That is even more than the watches. Great. And how many of you want to already doing this on an own automated way and trying to, let's say, customize it? For example, idea like a magic mirror in the bathroom. Oh, still some hands. Okay, good. So what we see, it's already here. It arrived at our homes. And we have a big impact in regards of life cycle. So one problem is the huge amount. The other problem is life cycle, this huge amount of devices. So we have this partially embedded devices. If you go to the next conference here, the ECS, the Embedded Systems Conference, you see many of these devices there, integrated chips and so on. But there's a lot. There's a thing about like each RFID chip on each container that is running on the world, on a ship or a truck, right? So to upgrade, it's very it's not very cost efficient. So you buy this once and want to have it for a longer time. So you need some you need some method or tool to not only provide a life cycle by upgrading the hardware itself, so you need to buy something new, but maybe also, and this could be a benefit to reduce the 70%, to do a life cycle from software perspective. So keep the hardware as a baseline, secured, and then go up and
update the software.
Update the software. Thank you. So we see this a lot in the industry. if you go to, for example, for a nuclear power plant, you have many, many sensors and such a thing. Sometimes you also have, like in the case of France, there was a situation where internet-enabled dishwasher was hacked from the outside, and it was included in the network of the nuclear power plant, so it was compromised. So this is part of security, but I will come to it later. These things are not out of the box thought by the developers. If I'm a dishwasher producer, I won't think about the use case. It will stand in a nuclear power plant or a highly secure area. No, I will think about that it will be standing in your home, where you have your light bulbs that you are managing with your mobile app. So we need to think about this too. Also, the testing, if you go for this. It's hard to test out of the box because you have some clients that you want to deliver your product, but other clients will buy too, and you're repurposing it. Like you all repurpose your Raspberry Pi for different projects, for example. So the impact is high, and if you go after testing to the auditability and traceability, who is logging in to my dishwasher? Who is logging into my Raspberry Pi? If I'm not monitoring, if it's not traceable, if it's not auditable, it's getting a huge security problem, which leads everything to this security topic. On the other hand, we have also the consequence of change. So if I, for example, go ahead in the nuclear power plant and update all sensors that are regulating or getting information about temperature, and I have a malfunction, I think this will be a great problem, a great deal at this point. At my home, okay, the thermostat goes up to 30 degrees. It's condemned. It's a little bit closer scope. But we need to think about the consequences when we change something. So I already talked about few issues, these challenges that IoT devices have, why they're also held back still up to date and can't take the velocity to go up and be more flexible and be greater than it is now and reach more people. But there are already approaches currently there. They're not fully developed, they're not fully here, but the ideas are there. And how to connect this, one part is to go for the architecture. Like in software architecture, where we had the design of a presentation layer, logic layer, and then the data layer, we have the same architecture or similar architecture here. So we go from the device itself that is sending messages, encrypted or not encrypted, it's decided by you. Then you have the gateway or the network layer that is transferring where you can run real-time analytics because it's close to the device, but the security sits here. And then you have the data center layer, and this data center layer is running all these core business processes, is doing reporting about the analytics that are coming out from the network layer, and it's accumulating and doing even further analytics. So we need also to think about if we have a similar approach like in software development here for IoT devices, why don't we go to also an approach in the picture? I'm still waiting till someone gets a picture. gets a big idea to also include this here. So we have the fourth person filled in. And this is why I think we need to go outside to the guys on this ECS and talk with them. Okay, get the idea what their challenges for developing the hardware is, convince them, and this is my perspective, convince them that let's standardize the logic, let's standardize the hardware, go for a baseline that all software developers that are running on top, including the network layer, can leverage the opportunity to abstract and have the software defined, developed on top, and then push it down. To take it even one step further, let's not only talk about how to develop software or applications for IoT devices, let's think about how to push this idea down to the device level. The reason is we run most of the parts, and this conference was focused on OpenShift most of the time. We running more and more applications in containers. Why not use the same idea also for IoT, that IoT becomes a container? Just a quick news that I read a few hours ago, that Docker is officially supporting the newest version, the Raspberry Pi and other ARM platforms. So I think it's a great little step for this to become true. The other thing that I'm proposing is that we go the open source way, because many companies like Azure, so Azure with Microsoft with Azure, AWS, and the Google Cloud Platform, they have IoT-enabled services that they provide. But at the end, it's closed source, mostly. And we need to enable others, or first ourselves, to get these projects, which you hear about just a few moments, to enable this project to get more collaboration, more teamwork, more partnership, and lift them up to be that thing that is delivered from the community. And this community will make, let's say, this much more easier. But for this, we still need the standardization. So don't forget the guys out there at the ECS that we need to talk with them. So finally, partnership. This is the most valuable part of this, and that's the reason why we talk here at the Red Hat Summit about it. I want to close on my end and hand over to Alexander about the Accenture vision of IoT.
Yeah. I'm going to define IoT a bit closer and the different layers we have there, and then hand over to Oliver. He will show how it works together with Red Hat. We identified more like 4 tiers. We have the edge tier where the devices live. We have the platform tier where all the control and data analytics stuff live. We have the enterprise tier, that's the classic software, and we have the public tier used for communication internally and externally. Got your pictures? Good. Using this simple categorization, we are able to capture lots of different deployment patterns, like devices in the wild and on-premise data centers, devices under lockdown, and everything else in the cloud. So it doesn't matter, we can picture it all. Going to have a closer look now at the edge tier. We have 5 main component types. We have sensors and actuators. Then we have the converters used to attach to old-fashioned sensors and make them available on the network. We have edge routers, gateways, and we have devices talking to humans, like your mobile or specific applications. There's different connectivity patterns. So we have devices going via a tag converter to the router. We have devices connecting to the router, other devices connecting to the edge gateway, and stuff like Raspberry IP-enabled and directly connecting to the network. Closer look to the platform tier. We have the different management functions for the devices up front, and on the lower side we have the adapters to get incoming data, have analytics functions in the middle, and then have output adapters moving data to the enterprise functions on the enterprise tier. I'm skipping the enterprise tier. That's the standard stuff we do every day anyway. Have a closer look at the public tier. It's probably should be an API gateway on top. The different services you need to manage or control access and transform data and connect to other platforms. Because one of the big problems.
Thank you.
It's a.
Don't forget that's on the internet.
Yeah, I have my car and I want to make my path lights come on when I'm close to home. And that's a big interoperability issue because they're living in totally different ecosystems. And there's not a big interest to make a car compatible with your light bulbs. But there's a solution. There's a platform of platforms integration with a middle tier. You know, you use IFTTT, or who uses IFTTT here? This is a part of a platform of platforms integration. You see temperature changes, or there's rain outside, there's an action attached to it. Here we have the car coming close to your home, and the lights go on. I think I've got one more slide. We see there's a lot of stuff going on in the open source area. Mostly, I see a lot of action in Eclipse, and they got donated lots of good stuff from Bosch and Eurotech. Cura is quite stable. Capo comes from a stable closed source version. Everything else is version 0.2 and in incubation, and it's really hard to make it work. So there's no demos at this time. Maybe next time. But I see there's a lot of activity in this open source area, so I'm happy about that. And I think we're going to see a lot of good things. And with this, I'm going to hand over to Oliver.
Okay, so we saw a little bit about DevOps and DevOps and IoT and the Accenture architecture view on that. And let me jump back to one of the pictures that we had before. So Johann was showing this as 3 bars a little bit. It was, if you listen to some of the presentations this year or even the last summit from Red Hat or Eurotech, you will be familiar with this picture. It's a 3-tier IoT stack that we showed since last year, I think. But talking about full IoT implementation and talking about DevOps, we like to shrink it down a little bit to just kind of the 3 different symbols and say this is our IoT stack. And when we talk about a solution in the IoT space, we're not done with just the IoT stack. And I will come a little bit from another side, but end up more or less at the point where Alex just left us with his presentation. So I can show a few things out there coming together between the view that we have as Red Hat and the architecture that Alex was presenting. So when you look into a kind of full-blown project as an example, you will see that we have several other parts in the solution. And those parts include, of course, things like analysis of your data, any big data analytics functions. It will include API management, hopefully, and also the old mentioned business applications that are out there, maybe some new functionality as well to develop over there, or integration. And on the left-hand side as well, some UI, some mobile connections so that you can access all the different things that are coming out of your IoT devices and maybe take some decisions and make something work the way you would like to work it. So to compare it to Alex or the Accenture architecture picture, here we have the tiers again. And I sorted them a little bit differently, and that's for a reason. I'll come to that in a second. But you see the IoT stack, the upper part of it, and the analytics is in the platform area, and the API management was one of the major parts he mentioned in the public tier. And the business applications, you called the enterprise applications, so that's just two different words for the same thing. And then for the edge, you see kind of the lower parts of the IoT stack, and to some extent, the mobile was mentioned there as well. When we look at this, we see that we have probably, from a DevOps point of view, we will have a DevOps pipeline for each of these little buttons that you see now there. So if you count them, you will find that we have 8 different DevOps pipelines. And, well, that's okay. We're having many different applications out there very often. But this time, it is that we have this as just little pieces of a solution. So all of them have to work together in a way. And if you have 8 different pipelines for just one solution, I think you get a feeling about, well, okay, this is going to be complicated to some extent, right? Okay. So now we have a few points where we can help you to make it a little bit more easy. And I think we're on our way. That was Johann mentioned already. This is a journey. We'd like to take the journey together. And the first thing that we like to mention is that for all of the things that you have in the data center level, you could use the tools that are coming along with something like an enterprise container platform. And I think you guessed what I'm talking about, so I will come to the product names a little bit later. I'll leave them out for the moment. Okay? So what we see is that we can bring all those data center functionalities quite easily into an enterprise container platform, and then we can use all the tools that we have there. So for rollout, I think you heard presentations about different options that you have. You can do a canary rollout, a green-blue layout, and rollout, and these kind of things. You can include a Jenkins to define the things that you're doing in your DevOps pipeline. So you can use the same tools, and so it all comes a little bit more together, and you can also combine those more easily if you're using the same tool sets. Okay? What was going to happen with those things that are outside of the data center? And the good news is that we're having solutions there. So if you look, for example, for the mobile side, you usually have some functionality in there that helps you to roll out new functionality to your mobile devices. If you have that kind of data center functionality, centralized data center functionality for the mobile side, it will include some kind of help for rollouts of new versions and these kind of things. The same is true for the IoT stack. So if you have a data center functionality for your IoT stack, it will include something that at least goes down to intelligent gateways or something like that. Okay? And I have a dotted line as well, so it means, okay, if the gateway is there, it usually, if it's possible to go down one more step to the device, it usually includes some functionality to do that. Let's try to think about what Johann was saying before. He was saying he was expecting that we see more things coming to the containers. And one of the possible next steps is that we see that the intelligent gateways might move into that environment as well. So we believe that on the long term, we will see things like containerized functionalities going down to intelligent gateways as well. So we're kind of prepared for that, you know, that we have our RHEL, and we have the Atomic project, so which is kind of making things small but capable enough to run containers on with very little effort, kind of. So that runs in small machines, okay, as long as they're kind of the right processors currently. Okay, so we'll see maybe something like that in the next few years coming up. And let's now talk a little bit about products. I'm from Red Hat, so I should talk about products. I think you were expecting that. If not, you should stand up now and go. But give me the chance to say a few product names now. Okay, so I think you guessed it. It was OpenShift I was talking about when I was talking about the container platform up there. And we have some good news for you here. So there's Ansible down there. Who knows Ansible? Okay, Ansible is for automating everything. Okay, so that's good for DevOps. And Ansible will, there was an announcement that Ansible will be included in the control layer of OpenShift, which is actually the product Cloud Forms included in OpenShift. And Ansible will be included in Cloud Forms in the next version. The announcement was, I think, today or yesterday. Okay, so that's a good part of the good news. Also, if we go from the right to the left, you see that we have 3-scale here for the API management. And 3-scale, if you like to have it not just as a service, if you like to have it on premises installed, it will be installed on OpenShift. You can only get it on OpenShift if you like to have it on-prem. Okay? So the next bubble was the analytics and big data part. I can just ask you to have a look into your agenda. There are a few talks tomorrow about things like Kafka and some of the things that are in that space. So there's some quite interesting talks tomorrow about that. So what you can do with OpenShift and big data and analytics. Then a little bit more left, you see the product set, the IoT stack from our partner Eurotech. And actually, that's kind of, I asked the Eurotech guys if I could say that. It is current, it's announced, but I think I'm not allowed to talk about dates. That's the point. I don't know the dates anyhow, so no problem. Don't come to me and ask me. The Everywhere Cloud functionality, which is the data center functionality of that IoT stack, is going to be on OpenShift very soon. Okay? So they will provide an on-prem installation of that functionality, also on OpenShift, so you can run it on OpenShift. And down to the left, the same is true, and I think that's announced a little bit longer now, and it's available already. The mobile application platform from Red Hat is also, the data center part of it is available on OpenShift. So the story is quite good currently, as you could see. And I was leaving out the little yellow box over there. And Alex wasn't talking about it. I was wondering why he wasn't doing that. I don't know. You just missed it. Yeah. Okay. So there's a functionality out there. You remember the car and the light bulbs? Okay. And there is a functionality out there, or there's an offering out there from Accenture, and that's called CPaaS, and you can do things like that with that offering. So this is kind of the full picture that I can present to you, showing that we're kind of prepared to go the way together with you, Accenture and Red Hat. We're open to help you to step into the fantastic IoT world, and we're really looking forward to it. And we would like to create all the DevOps things that we have to do to be the 30% instead of the 70%. Thank you. Any questions? Yes.
Yeah. So the main idea is we have already some protocols that are standardized, but we still have the hardware issue that it's so diverse and it's so a lot of them. And if you type lot, it's like IoT. No, they're not a capital T.
I think we entered a totally different world when we were going from just IT to IoT. Right. So we entered the OT world, and the OT world is totally different. And yes, we learned that all of a sudden we were very proud that we were offering 13 years of support for Linux, okay, as Red Hat, okay. But then we were talking to those guys, and they were asking questions about time frames that are totally different. Okay, if you talk about nuclear power plants, you have like 30 years, 40 years, and these kind of discussions. So I think the IT side has to learn to some extent. So we're not used to it. So we need to kind of find out what's.
Fix this whole thing. Which
Sorry?
is awesome. I mean, I don't want to put all that hero stuff on you guys. You can totally fix it and make a lot of money.
The point, we have to, well, okay, let's take that offline. That's okay. Now, I just wanted to come back quickly to the standards question. I think standards is very difficult. When you look into the OT world, there are, if you like, per industry, there are standards. And not even just one. There, for the same thing, you'll have like 5 or 10 standards per industry in that area. So that's also a totally different world. So in the IT world, we're used to, well, okay, I just use TCP, IP, and everything, so I can talk to everybody fine, okay? But all there, look at the OT side of the world, and you will find crazy things you never heard about before, maybe, okay? So all those bus systems and whatever, so very many things. Yes, we are supporting, of course, things like MQTT, but this is really on the IT side, so that's easy. The other side is kind of the tricky thing, and that's also why we as Red Hat have to work together with partners like Eurotech to make sure that we have somebody on our side that really understands this part of the solution and this part of the requirements as well, and helps us to kind of get to that side and support whatever is needed.
Yeah, but the main focus here is security at this point.
Right.
And currently, the IoT devices or even surveillance cameras are designed, the design is, the core design is secured, or it's a security by design. We should go for a security from design. Yeah, right, but we should go for a security from design, right? Yeah. So to go a layer up, let the IoT device do its function, but do it plainly. But the security layer is on the network layer. The security is when the connectivity drops in.
Of course, the containerization itself will help vastly with security, but it doesn't solve everything. There still will be the libraries that are included in containers.
Definitely.
And of course, consumers can end up with nothing. So
I fully agree, but we will never solve the kind of the underlying major problem, which is people don't pay for security, they don't care for security. If you go to the if you go into the enterprise side, everything's fine. Okay, yeah, we can work on a solution over there. If you go to the private webcam thing, they would just buy the cheapest device. Okay, so they don't care. And even if that's part of a botnet, they don't care because they don't get hurt.
Right.
Somebody else gets hurt.
Right.
Okay, so why should they pay for it? Okay, so now you're coming into something where I say, well, okay, we will see many things develop over the next couple of years in our governments. So I think we will have some requirements to work on that side as well. Absolutely, I'm with you. I just say if you put security inside, that costs something.
Right.
So your product's going to be a little bit more expensive than the others, and people are buying the cheapest one. So that's.
No, sorry, I'll let you.
So,
Thank you.
Okay. Thank you very much.
thank you very much, Ford.